Hi guys, I want to talk to you a little bit about some things that people might have been having trouble with in terms of the periodic table. So again, it's one of these where we want to make sure that nobody has any questions and that I can address any issues that we have. Okay, so in this first column here, whenever I was talking about different columns on a periodic table, on this first column we have hydrogen all the way to francium. Okay, so this is francium here, this is hydrogen here. So this is your first column, this is going to be your second column, this is going to be your third column, fourth, fifth, sixth, seventh, and eighth. Now, why is this important? Well, the reason why this is important because this tells you the number of valence electrons you have in your outer shell. So this one, okay, this first column is going to have 1 valence electron in its outer shell, and this one's going to have 7 valence electrons on its outer shell. Now, elements want to get to 8. It's called the octet rule. So with the octet rule, if elements want to get to 8, that means that the elements are going to behave in such a way to where either they're going to share their electrons or whether or not they're going to donate their electrons. So in this instance here, we have 1, 2, and column number 3. That means that they are going to give away their electrons. Now, you might be asking the reason why. Well, the reason why is because it's a lot easier to lose 1 than to gain 7. It's a lot easier to lose 2 than to gain 6, and it's a lot easier to lose 3 than to gain 5. So if you lose your 3, or you lose your 2, or lose your 1, then that means that your next or your previous shell is filled. Since it's filled, then that means that you're satisfied or you're stable. Now, this is going to be your fourth column. I'm only having you worry about carbon, and we know that carbon forms covalent bonds. So if that's the case, then that means that it's going to form covalent bonds with your other elements. Now, 5, 6, and 7, it's a lot easier for them. Okay, for this one, this has 5 valence electrons. It's a lot easier for them to share 3 than it is for them to lose 5. It's a lot easier for them to gain or share, it's a lot easier for them to gain or share 2 than it is to lose 6, and then it's a lot easier for them to either gain or share 1 as opposed to lose all 7. Okay, so hopefully this cleared it up a little bit in terms of how to read a periodic table. Now, something else I wanted to talk about, and that I told you that I was going to talk about in the previous video, is that I want to talk about this idea of adhesion and cohesion. Okay, so here's our penny. Now, our penny is going to be our adhesive material, and then this is our water. So this is a bulb syringe. I did not have a pipette, so I'm going to have to use my son's bulb syringe. So if we were going to add drops on top of this penny, try that again. Okay, so if we're going to add drops to this penny, if you can see here, oh, I made another drop there. If you can see there that the water stays on the penny. Okay? If the water stays on the penny, that's considered adhesion because it's water with the penny. So these are two unlike materials. Now, cohesion occurs because the water is actually forming droplets on the penny, and not only that, it's creating surface tension. Now, if you were able to see this here, and let's see if we can do this here. Okay. So if you're able to see that there we go, that there is actually a nice little dome forming around that penny. And so that doming occurring is actually creating surface tension. And it's creating surface tension because there's cohesion. Okay? And so, again, with the water being attracted to the penny and not sliding off the penny, that's considered adhesion. The water that's doming and it's creating surface tension around the penny, that's considered cohesion. All right, thanks guys.